This is Geometry A, Unit 6, Lesson 10, Rectangle Proofs. I have on the screen a rectangle. First we need to define what a rectangle is. As you can see from all of these drawings, a rectangle is a quadrilateral. That is, it has four sides. And it has four congruent angles, or four right angles. You may recall that the angles of a rectangle should add to 360, and 360 divided by 4 is 90. So each angle has a measure of 90 degrees. So a quadrilateral with four 90-degree angles is of necessity a rectangle. Okay. Now that said, there are some properties of rectangles that we need to be familiar with. Number one, a rectangle has parallel sides. So a rectangle is a parallelogram. Okay. Not only that, then, it has all the properties of a parallelogram. Opposite angles are congruent. And of course, opposite angles are congruent because all the angles are 90 degrees. Opposite sides are congruent. Opposite sides are congruent, just like in a parallelogram. The diagonals of a rectangle bisect each other, split each other in half, because it is a parallelogram, and that's one of the properties of a parallelogram. I'm going to get more specific with that here in just a minute. Okay, so opposite angles are congruent, opposite sides are congruent, the diagonals bisect each other. Have I missed anything? I think that's about it. We would say that adjacent angles or consecutive interior angles are supplementary. They add to 180. Okay, and of course, since they're all 90, they do add to 180. So all those properties of a parallelogram apply. But here's a property that applies just to rectangles. In a rectangle, the diagonals are congruent. That is, they are exactly the same length. This is not true of all parallelograms. In parallelograms that are tilted, one of the diagonals is longer than the other. So in this case, the diagonals are congruent. And this is an if and only if. It flows both directions. If a parallelogram has congruent diagonals, then it is a rectangle. If a parallelogram is a rectangle, then it has congruent diagonals. And we can use this to answer all kinds of questions, but this is a unit on proof, so let's go ahead and do a proof. Okay, so let's get rid of all but one of these. Okay, and add a new layer here. So we're going to prove the diagonals of a rectangle not bisect each other, are congruent. Okay, so I'm going to draw both diagonals, and I'm going to label all the vertices. Okay, so here we go, the diagonals. Okay, and I'm going to label them B, I, R, D. Any word that forms out of that is purely coincidental. Okay, so B, I, R, D. All right, so we're given this much information. Given BIRD is a rectangle, and all that entails. Prove ID is congruent to BR. That's what we're trying to do. Prove that ID is congruent to BR. All right, so let's go ahead and get to it. This is like the programming in GPS when I want to take a car on a trip. I have my given, I have my starting point, my home or my current location, and I have my destination, what it is I'm trying to prove. So in a proof, and I'm going to start out with a 2-column proof, we have our each step, it consists of a statement and a rule or a reason. We must always justify every statement with the rule that allows it. And the very first step of a proof, you're never wrong to do this, should be the given. What are we given? VIRD is a rectangle. And for this purpose, I'm going to indicate this symbol for rectangle. How do I know it's a rectangle? It was given. That's the one assumption you can make in a proof, that the given is true. Okay, now down here I'm going to put as a final step, and I'm putting it down a ways because I don't know how far. I'm not putting a number because I don't know how many steps yet, but I'm putting my final conclusion. ID is congruent to BR. And I don't know the rule or the reason that says so yet, but I will. Okay, all right. So let's go ahead and break this out here. What we really are looking at here is 2 triangles. We've got this triangle right here, right? And we've got this triangle right here. I'm going to sketch them. I'm going to sketch one here and sketch the other here. Okay, and we're going to label what we know about them. I, D, and B. B is a right angle. And we know B, D, and R. And angle D is a right angle. Okay? All right, so here's what I know. I know that the opposite sides of a rectangle are congruent because a rectangle is a parallelogram. So I'm going to start by saying 2. BI is congruent to DR. And the rule that says so is opposite sides of a rectangle are congruent. Okay. Now in step 3, I'm going to say BD is congruent to itself. BD is congruent to itself. BI is congruent to DR, and BD is congruent to itself. So BD is congruent to, and I'm going to say DB for reasons that will become apparent here. For what reason? What reason? What is the rule that says that anything is congruent to itself? We talked about this before. Anything is congruent to himself. I'm as tall as I am. I have as much money as I have. My hand is exactly the same shape as my hand, right? We call that the reflexive property, not reflective. It's not a mirror. Reflex. It's like a doctor hitting your knee with a rubber mallet. Reflexive. Reflexive property of congruence. Okay, DB is congruent to DB. Now check out what I've got here. I've got a side congruent to a side. Okay. Oh, and one more thing I need to state. Angle. Angle IBD is congruent to angle RDB. How do I know they're congruent? Well, we know that they're right angles, and right angles are congruent. So right angles are congruent. There's a rule that says that. Right angles are congruent. Okay, looks like I need to add a little bit more space here. Luckily, I'm on a computer program that allows me to do that. Okay, so let's go now. Step 5. Okay, now we've got a side congruent to a side. We've got an angle congruent to an angle. We've got a side congruent to a side. So there's side, angle, side. So the triangles are congruent. So triangle IBD is congruent to triangle RDB. And they are congruent, step 5, by side, angle, side. The side, angle, side theorem of congruent triangles. Okay, now what do we know about congruent triangles? They have congruent corresponding parts. So step 6, ID is congruent to BR because, step 6, corresponding parts of congruent triangles are congruent. Quod erat demonstrandum, I said it, therefore I proved it. Quod erat demonstrandum, right? And so there you have it. There's a proof that the diagonals of a rectangle are congruent. So if you have a rectangle, they are congruent. Now, I did mention that the converse also applies. And that is that if you have a parallelogram with congruent diagonals, that parallelogram is a rectangle. I'm not going to prove that right now, but it's certainly provable. Okay, but I'm going to spend a little bit of time showing you the kinds of problems you're going to be given in this case. They love to give you algebraic problems. Problems involving labels that have X's or Y's or M's or N's or A's or B's or C's in them. So, for example, we have rectangle ABCD. Rectangle ABCD. Okay, and in rectangle ABCD with center or midpoint E, AE is, let's say it this way, AE, and if I draw it without a bar above it, it means distance. Distance AE is 4x minus 10, and C, and let's go BD, distance from B to D is 6x plus 30. Okay. Find x. Actually, I'm just going to say find the length of AC. Find the length of AC from this information. Okay. Here's what I know. E is the midpoint. So BE is congruent to DE. And the diagonals are congruent. So AE is congruent to CE. So all 4 of these segments are congruent. Okay. Now AE is half. It's right here. 4x minus 10. BD is the entire thing. BD is the entire thing. So it's 6x plus 30. So whatever AE is, BD is twice as big. So BD equals 2 times AE. Okay, so let's fill in what we know. AE is, or BD is 6x plus 30. And AE is 4x minus 10. Okay, let's see if I even set up a problem that's solvable. Distribute. This is all algebra now. 2 times 4x is 8x. 2 times 10 is 20. 6x plus 30. Subtract 6x from both sides. And add 20 to both sides. So we get 50 equals 2x. Divide by 2. Looks like I did make it solvable. X equals 25. Okay, so that's what x is. So now sometimes the temptation is to say, we're done, we found x, but we need to find AC. All right, AC is 2 segments. So AC is the same as BD, right? AC equals BD. And BD equals 6x plus 30. So AC equals 6x plus 30, and AC is 6 times 25 plus 30. If I have 6 quarters, I have $150. $150, 150 pennies. 150 plus 30 is 180. So AC is 180, and if they'd asked for it, AE is half of that, is 90, if they didn't ask for it. All right, so that's kind of how we use these facts. The diagonals of a rectangle are congruent, and if a parallelogram has diagonals that are congruent, it is a rectangle.